Hello everyone, let me introduce my name is Leader First Andika from 11 Maret University. I will present about integration of yeast cell flocculation with continuous ethanol fermentation using laboratory scale of integrated aerobic and anaerobic Baffled reaction. The outline of this paper is consists of introduction, methodology, result and discussion, and then conclusion. The first for introduction, this paper will concern how to make ethanol to be cheaper. Shift the gasoline fuel to renewable fuel, especially ethanol, has been carried out to reduce the dependence of fossil fuel. Its expectation is ethanol will be widely used and become a substitute for gasoline. Unfortunately, the price of ethanol is quietly expensive, so high it's hampered to the realities of goal, especially in the pandemic situation of coronavirus. Regardless of the situation, some factor interface the high price of ethanol, their raw material source, and productivity of fermentation method. It is necessary to study how an ethanol price will be competitive for biofuel source. The way are how to produce ethanol from waste material and improve fermentation performance. The methodology first is a reactor. This is reactor of our study. It was made from a glass board and had a working volume of 10 liter. The second is inoculum development. The inoculum was developed is two steps. Firstly was activation inoculum and secondly start inoculum. Activation inoculum was activated from stock culture by inoculating Saccharomyces cerevisiae into medium containing yeast extract, peptone, and glucose. It was incubated in a shaker incubator for 24 hours at 30 degrees Celsius and rotating speed of 125 rpm. 10% volume per volume of activation inoculum was inoculated in the medium of started inoculum consists molasses 30% weight per weight. It was incubated in a shaker incubator. And the third is in situ flocculation, a startup process or batch process. 9,000 molasses medium 30% weight per weight were filled into the reactor and distributed equally into compartment A and B. 1,000 of starter inoculum was inoculated into the molasses medium will be recirculating switch in on to distribute molasses medium and inoculum homogeneously into compartment A and B. First step was the start-up process which incubating was done at the room temperature and recycling was switched on. The start-up process was run to reach a cell density 1 multiplied by 10 to the power of 8 cell per millimeter or higher, which the was time to add flocculant into compartment B. Feeding medium of molasses 30% weight per weight was flowed from feed tank into compartment A at a flow rate of 0.5 liter per hour. Initiated in continuous operation. The ethanol product would be stored in the product storage. The sample would be taken out from the bird periodically every 6 hours from analyzing some parameter response etc. Cell density, residual sugar, ethanol level. Well, the continuous operation was run every population over the cell density and cell record occurred. The next population would be done when the cell density reached 1 multiplied by 10 to the power of 8 cell per cent per milliliter of higher. The flocculation will be repeated at the suitable cell density until the fermentation process stops. And the resulting discussion profile of cell density in the compartment A and B by feeding medium molasses 30% with probate flow rate 0.5 liter per hour show that the start of over 18 hours of incubation time to reach a density of 4.3 multiplied 10 power by cell per milliliter. The cell density indicated flocculation must be started. After that, the power show the cell density decreasing after flocculant is added and increasing when the molasses medium is fed as the marking of continuous fermentation start. These phenomena have similar process profile until the process ends. The second is profile of residual sugar in the compartment A and B. Refer to the profile of the residual sugar. The medium processed during 198-hour fermentation can be calculated. The first step of batch process 10 liter of medium and the next continuous fermentation process is 78 liter medium. So 88 liter of molasses medium 30% weight per weight. For the equal duration of batch method runs 4.1 cycle of batch is able to process 41 liter of medium. One cycle is 48 hour and 10 liter per cycle. Therefore, the continuous fermentation has 1.9 times higher capacity than the batch one. And then this is profile of ethanol concentration in a compartment A and B. Continuous operation cover 150 hours from 42 to 192 hours of fermentation and the ethanol production will be counted from compartment B. Refer to the explanation, the continuous fermentation produces ethanol as much as 6,070 to 75 grams of ethanol. So the productivity of the reactor is 4.05 grams per liter hour. It's higher than the batch operation. And then this is a comparison of productivity of some continuous fermentation in the ethanol production. In the recent study, we have medium molasses, microdiameter Saccharomyces and process continue have a productivity 4.05 gram per liter hour. And the conclusion, the integration of Saccharomyces cell flocculating with continuous fermentation using a laboratory scale of Aerobic was already carried out. Continuous fermentation with in situ flocculation was stable to run for 198 hours without significant defection. It processed 88 liters of molasses medium, 30% weight per weight or equal to 1.9 times the similar volume of the batch reactor, while the ethanol productivity was 4.05 grams per liter hour and it was higher than batch one. Thank you for your attention and see you